had a question about how to graph um, how to graph 30 additive tones. Um, so the way to think about it is actually one tone that you're building with 30 partials. Um, but the way you're going to graph graph audio data, it's going to be the same for three you know a three partial tone or you know a 300 partial tone. It's going to be all the same. So if I create some oscillators with amplifiers on their own envelopes, and this isn't going to be exactly like the assignment, but I'll show you how to graph um, a tone with multiple partials. So I'm going to create some envelopes here. So this will be one of my partials, and then I'm going to copy paste to create another one. So I've got an envelope here and an envelope there, and I'm going to change the other one a little bit so we're not dealing with the exact same thing. Okay, and for frequency, we're going to have, again, for the assignment, you'd have some MIDI input, but I'm going to do it this way just to demonstrate the graphing rather than the MIDI. Sorry, I don't need that because I'm going direct. So any number I get here, I'm going to multiply by 2 to get a frequency that's going to be always an integer multiple that's double this one. So first partial. So we'd have in your 30 partial. Let's just change this language. So it's going to be a 30 partial tone. So when you're dealing with 30 of these, you might you would do the process where you're sending from a single message box to all of these at once. So you're not having to repeat these message boxes. But since I'm demonstrating with 2 and mainly demonstrating how to graph, I'm doing it this way. So we can sum these. And to sum, so this is kind of a shortcut to summing. I could take any number of signals and combine them to the left inlet of an amplifier to sum them all together. instead of doing signal addition after signal addition after signal addition. I could just sum them all this way. So I might have lots and lots of signals coming into this one inlet of a signal amplifier. And so after that, to graph any signal, we're just going to take the output of that signal and write it to a table. So if I put an array, so the key here is array size. So I need an array with a size that is going to match the amount of time that the thing I want to record takes. So here I've created an envelope that the entire thing here is going to take 1100 milliseconds. So this part of it is shorter than this part of it. So this envelope takes 700 milliseconds. This one takes 1100 milliseconds. So the entire envelope takes 1100 milliseconds from attack to decay of the longest envelope. So 1100 milliseconds is going to be 1.1 seconds. So you have to consider the length of the envelope that you create and convert that to size of an array. So graphs are going to record sample by sample. So you got to think about, this is going to take 1.1 seconds, or whatever the length of your envelope is. The assignment, I think, asked for 10 seconds, but this is 1.1 seconds. So how do I convert that to samples? My sample rate, if I look at audio settings, my sample rate is 44/100. So I need that many samples in my graph times the number of seconds that I want to graph. So in this case, it's 1.1. So I could, open a calculator, zoom out, say 1.1 times my sample rate. So that's the size of my graph for an envelope that takes 1.1 seconds. So that's the size I put in my array, and I click OK. Now I have an array. So then I use tab right here. Tab right tilde, and I say the name of the graph. And I also need to tell tab right when to start graphing. So we need a bang to say start graphing. I should also, for good measure, just start my envelopes at the same time. So I could say use the same bang, do that. Or if I had a message send, I could send, use a receive here and send the message bang to this, and send these values to these VLines and have receives. And if I had 30 partials, that would be the way I would do it. Now, save that, give this a value. Now, to write a signal, there has to be a signal flowing. that means DSP has to be on. There we go. There's our signal.